Hello viewers, in today's class we are going to discuss two very important problems from range of functions, right? So in this lecture we'll see how to find the range of this function fx is equal to signum of x square, and in the second problem we have to find the range of the function g of x, which is equal to signum of x square minus 2x plus 5, right? So in this class we'll learn how to find the range of the functions involving the important signum function, right? So before finding out the range of these two functions, let us first revisit the definition of signum function. So viewers, signum function is a very important function in mathematics, right? So here I will define signum function. Now see, signum of x is defined as signum of x is equal to positive 1 whenever this input x is positive, right? So signum of x takes the value plus 1 whenever x is greater than 0 or x is positive, right? And signum of x is equal to 0 whenever x is equal to 0. And signum of x takes the value minus 1 whenever x is less than 0. So this is the definition of signum function, and we are going to utilize this definition to find out the range of these two functions. So now let us first take the problem number 1. So here we have f of x is equal to signum of x square, right? Now see, here the domain of this function is the set of all real numbers, right? So domain of f of x is the set of all real numbers. So signum of x square can now be defined by using this definition, that is signum of x square will take the value 0 whenever x square is equal to 0, right? So here we are using this part. So signum of x square is taking the value 0 whenever x square is equal to 0. So this implies that x should be equal to 0. So whenever x is equal to 0, then signum of x square is equal to 0, because signum of 0 square, that is signum of 0, is equal to 0, right, by this definition. And signum of x square takes the value positive 1 whenever x square is greater than 0, right? That is because x when x is any real number, then x square is always greater than 0, right? Because we have already taken the case x is equal to 0 over here. So whenever signum of x square takes the value plus 1, then x square should be equal to 0, which is obvious because this is a square term. So we can say that whenever x square is not equal to 0, then signum of x square takes the value plus 1, right? So now from the definition of range of a function, we can see that signum of x square only takes the value 0 and 1, right? So the range of this function f of x is equal to signum of x square is equal to the set containing only the numbers 0 and 1. So now we can define this function, that is signum of x square, from the set of real numbers to this set, right? That is 0 comma 1. So this is the domain of this function, because here x can take any real number, and whenever we square the real number, then we get either 0 for x is equal to 0, and for all other values which are not equal to 0, we always get a positive number inside this signum symbol, right? So we have 1 here. So the range of this function is 0 comma 1. So now let us consider the second problem. So here the function g of x is defined as signum of x square minus 2x plus 5, right? So now we'll again apply this definition to find out the range of this function, right? So what we will do here, let us rewrite x square minus 2x plus 5 as x square minus 2x plus 1, because we are going to make it a perfect square, and here we can write plus 4, right? So that 4 plus 1 is equal to 5. So x square minus 2x plus 1 is now equal to x minus 1 whole square plus 4, right? So now we can write this function like this, that is x minus 1 whole square plus 4. So now let us concentrate on this term, right? Now see, x minus 1 square is always greater than or equal to 0, right? For x is equal to 1, this term is 1 minus 1 square, so this term is 0. Now when we add 4 to this term, then x minus 1 whole square plus 4 is greater than 0, right? So this term is always a positive term for all values of x belonging to the set of real numbers, right? So whatever be the value of x here, either positive, negative, or 0, this entire term is always greater than 0, right? So it means that this term is always positive, right? So g of x is equal to signum of a positive quantity, right? Because this quantity is always positive for all values of x belonging to the set of real numbers, right? So now let us apply the definition of signum function. So signum of x takes the value plus 1 whenever x is greater than 0, right? So it means whenever this x is positive, then signum of x is positive 1. So here we have always plus 1, right? So g of x is equal to plus 1 for all x belonging to the set of real numbers. So this suggests that the range of this function g of x consists of only one number, that is 1, right? So this is a singleton set, and the range of this function is it consists of only one element, that is 1.